but it's a good time now to revisit some instruction from algebra. Okay, so we're going to deal with coming up. We talked the other day about slope. We talked about the idea of being perpendicular and what the slopes have to be to one another so that lines are perpendicular. Now what we're going to do is we're going to take that one step a little bit further, and we're going to come up with the equation of a line, which is a concept that maybe took a couple months last year to kind of build up to, okay? And then you practiced it for a long time. Now we're going to start using it, and we're going to start using it over and over within this course. And when we get to Algebra 2, it's one of the key procedures that you're going to use in Algebra 2. When you get to college algebra, it's a key procedure in Algebra 3, essentially college algebra. We use it all the time in trig, and without it, you are not going to ever be successful in calculus. Okay, so finding equations of lines is one of the top 3 things that I feel, and you ask any other math teacher in the high school level or even college level, what do I need to be able to do algebraically when I leave high school, okay, to pursue other mathematical areas? It's coming up with equations of lines. Okay, it's a very, very fundamental component to all of the rest of mathematics. Okay, so we know a couple things. We know how to find slope, right? Okay, so this is question 2. So throughout answering these parts in question 2, we're going to analyze that idea of finding the equation of a line. Okay, so the first part I've already done is graph these points in this manner, and then allow the intersection, or rename the intersection of AE and BD, rename it C. So in your homework, you're going to see like 4 graphs that you have to pick from that indicates this is the set of 4 points that they gave me with the correct labeling and all that kind of stuff. Okay. The next part says find the slopes. Okay. But it only wants the slopes of what I've got up there highlighted as the blue line AE and the orange line BD. Okay. So what was the formula for finding slopes? All right, y2 minus y1 over x2 minus x1. Okay, so when I want to find the slope, or you want to find the slope of AE, okay, that point right there, and that point right there, those are going to be your x1, y1, y2, or x2, y2s, right? Okay, does it matter which one's which? No. Okay, so when I subtract, I just got to make sure that I subtract the numerators in the same order that I subtract the denominators. So I'm going to go 4 minus negative 8. Okay, so that's going to give me 12. Then we're going to go negative 2 minus negative 8. What's that going to give me? And that's going to reduce to 2. Okay, so 2 is my slope, right? All you have to do is be able to subtract to find slope. Okay. The slope is 2. Nice. We're going to do the same exact thing then for BD. All right. So BD then is going to be using those 2 word pairs. All right. So I'm going to go y2. What do you want y2 to be here? Say again. Negative 1. Okay. So negative 1. So then y1 would be negative 3, right? So negative 1 minus negative 3. And then I've got to go negative 7 minus negative 3. And I think it's beneficial, especially if you're missing a lot of these. You're missing the signs on them. Or even in this one, you would mess up the quantities as well. If you are struggling with subtracting negatives, write that out like I have up there. And it's going to give you a visual of negative 1 minus a negative 3. And you know when you see these 2 back to back, it becomes what? Positive. Okay, so negative 1 plus 3 is 2. Negative 7 minus negative 3? Negative 4. What's that reduced to? Negative 1 half. What is the relationship then between 2? Okay, good. They are. So 2 and negative 1 half are opposite sign reciprocals. So the question is, how would you describe those 2 angles, ACB and ECD? How would you describe them? What kind of angles are they? These are perpendicular, right? That's what the opposite sign of reciprocal tells us, right? So what type of angle is that one there and that one there where those two lines meet? They're right angles, okay? We got right triangles, okay? The next thing they want us to do is to come up with the ordered pair for the location of C, okay? And if you cannot do this, you see down here that you're going to struggle with the rest of the question, right? Because you want distances of BC and DC. If I don't know the ordered pair of C, I can't find that distance. Does that make sense? Okay? So we need to be able to do this. Now, you're going to find out, and it's just some of you are going to get lucky, okay? And the question that's presented for you, you're going to be able to tell the location of C just looking at the graph, okay? That is not something that you want to kind of say, I'm always going to be able to do, okay? Because I'm going to give you instructor creative questions on purpose that you can't do that with, okay? Because you need to know how to make equations. The end of course exam will ask you to write equations, okay? So the way we do this, okay? I'm going to actually go to another slide here to explain this concept real quick to you. You guys remember from last year you had this formula, y equals mx plus b, right? Okay. What did the m stand for? Slope. Does anybody remember what the b stood for? Y-intercept. Okay. This format is called slope, intercept, form. Okay. You can use that. Now, that's what people remember the most. It's kind of, it flows off the tongue pretty. Y equals mx plus b. It's something we kind of beat or train into our heads to just know. All right. But I think in using that one to come up with our equations from information in the graph, that's not a real easy kind of progression to get the actual specific equation using that, okay? I'm more of a fan, and I'll let you guys choose whichever one you want to use. I'm a fan of this one. You remember what that was called? Or have you seen that one before? Okay. This one is called point. Okay. And the point is the x1 comma y1. And m is your slope. We call it point slope. Okay, point slope form. Now, people say, well, those are two different things. They are not. They are the exact same thing. Okay. The blue one is just a special case of the red one. The red one will allow me to find any equation that I ever want to. Okay, I have a line. The blue one is then it's just a special one when I know a specific point. Okay. So essentially, what this is saying is, in this one here, your x1 comma y1 that we're seeing down here, okay, is actually the ordered pair 0 comma b. It's the y-intercept. Does that make sense? Okay. And just to give you a little bit of algebra that proves that if this is an equation for any line, okay, where x1 and y1, like I said, those are the points that is on your line. Well, if that point becomes 0b, okay, so the x value is 0. Would you agree any y-intercept is going to have an x value of 0? Okay, any point on the y-axis has an x value of 0. And then we just have chosen b to be that y value, that height that you're on the y-axis. Okay, use any constant, any letter that you want to represent that constant. But if x1 and y1 down here are 0 comma b, you'll get y minus b is equal to m times x minus 0. Does that make sense, everybody? When I evaluate that, let's do this multiplication here. What's x minus 0, first of all? What's 3 minus 0? 3 minus 0? 3. X is just a number like 3, right? So x minus 0 would just be x. So m times x is mx. Does that make sense? I've got y minus b equals mx. Y is equal to mx plus b then when I solve for y. Does that make sense? Okay? So I want you to understand my goal for you algebraically is not to learn a formula and say, I know exactly what that formula is and I can use it every time. That's nice. Okay? But math is about understanding where those things come from and what allows you to do what you do with them. Okay? So this formula here is the reason for y equals mx plus b being what it is. Okay? Because that key point, x1, y1, is your pair of 0, comma b. Does that make sense, everybody? Now, talking about it a little bit more, draw a picture here. If I've got a x and y axis, let's say this is my line that I'm interested in. Okay? How many points are on that line? Infinite, right? Okay? So if I have this point right here, x1, comma, y1, and this one right here, x, comma, y, okay? You should be able to find the slope between those two things, right? Okay? If this point were right there, should you be able to find the slope between those two? Should that be the same slope that it was when that point was here? Yeah, the slope on any line is constant, right? Well, here, so when I use these 2 points, okay, let's go through a little bit of algebra here to see what happens when I use those 2 points to find slope. Okay, so you guys know slope is rise over run, right? Rise over run. And rise is your difference in y's, right? Okay. Now I'm going to take this y value minus that y value. That's what we've been doing the last couple of days, right? Find the slope, take the y value, subtract it. Now on the bottom, you would take the x values and subtract in the same order, right? Okay. So when I say m equals y minus y1 over x minus x1, is that an equation? I'm stating 2 sides are equal, right? That's an equation. And I can now solve an equation like this because you can either say it's a proportion because it's 2 ratios that are equal, or you just say I'm going to multiply by the least common denominator, which would be x minus x1. I multiply both sides by x minus x1, I get this. M, x minus x1, equals y minus y1. I rearrange that, I use the symmetric property to rearrange that. Does that leave me with y minus y1 equals m times x minus x1? Is that the point slope form that I gave you? Okay. Now here's the thing. What happens when this thing becomes that point right there? Well, x just went to what? Okay, so that point becomes the y-intercept. So the x-coordinate of your y-intercept is always 0. And now we don't want to call this y1 anymore. We could. If you want to use y1, that's fine. But a lot of times we just use a value of b to represent that. Okay, so now I plug those things in here. y1 is b, so we get y minus b is equal to m times x minus 0. If we solve that, we get y equals mx plus b. Does that make sense, everybody? That's where those formulas come from. It's just coming from slope, okay? And then solving for that y component. So, how do we use that? Come up here. and I don't care which one you use. I'm going to use, for the most part, y minus y1 equals m times x minus x1. Okay, I think that's going to be much more algebraically friendly to you. Okay, so I'm going to find the equation of AE. So I'm always going to set up this generic formula. Okay. Now the x1 and the y1, those are your points. That is on your line that you're trying to find the equation for. Okay. How many points are on our line AE? How many points are on this blue line? There's an infinite number of points on there, right? Okay. You can use any one of those points that you want to. It does not matter. Okay. But do I really know what the ordered pair of that point right there is? No. Okay. It's not happening at a real nice spot. Okay. That would be a real nice spot right there, correct? That would be a real nice spot, maybe right there. Okay. Because that's kind of the intersection of those major grid lines, right? Isn't this also on AE? Wouldn't that be a good point to use? Okay, because I already know it's ordered pair. I don't have to count or do anything that I would have to do if I'm going to use this one. Okay? Or is this on AE? Yeah. Okay? It doesn't matter. As long as you choose one of those infinite points that you know shows up on that blue line for x1, y1, you're good to go. So I'm going to plug that stuff in. I'm going to go y. Y always stays y. Your y1, in this case, I'm going to use that point. So my y1 will be 4. So I go y minus 4. My slope for AE was 2. And my x1 would be negative 2. Okay? So it's always y minus y1. It's always x minus x1. So that's where I get that x minus a negative 2. What's x minus a negative 2? Same as. What's minus a negative? Yeah. Okay? So now I have y minus 4 is equal to 2x plus 4. We're going to distribute that 2 through. Add 4 to both sides. Get y equals 2x plus 8. That's the equation of AE. Does that make sense? Okay? We need to be able to do that. Now, to show you that it doesn't matter, and I'll do this quickly, that it doesn't matter whether I chose A or E. If I go y minus negative 8 is equal to 2 times x minus negative 8, okay, plus y plus 8 is equal to 2x plus 16, right? Subtract your 8 from both sides, gives me 2x plus 8. Is that the same equation? Okay. If I were to use this point right here, I believe that point is going to be negative 6, negative 4. Now I have to count away from 0, 0 to locate that, and my major grid lines are going by 2s here. If you use negative 6, negative 4, you should still get 2x plus 8. Does that make sense? Okay. If you used that point right there, you should still get 2x plus 8. But we're going to have a really, really, really hard time of getting exactly what that point ordered pair is, right? Okay. So we want to use, we essentially want to use ordered pairs that are rational numbers, okay, meaning they can be written as fractions. And the best type of rational numbers that we want to take are integers. So they're whole numbers, positive or negative, okay? And that's going to make your algebra a little bit easier when you solve for these equations. So that's what equation AE is, okay? Y equals 2x plus 8, okay? Now, I told you can use y equals mx plus b, so let's try to find the equation of BD using that technique. Y equals mx plus b. I think this is harder, okay? It's not as, using y minus y1 equals m times x minus x1. It's simply just plugging in x1, y1, and m and solving for y, okay? Here, you've got to do a little bit different work, okay? Ultimately here, when we're going to use this one instead, we have to solve for b, okay? We know our m for BD plus negative 1/2, right? Okay? This is kind of the structure that you're going to want set up when you do this, okay? Your y and your x in this situation are going to be a point now that is on BD. Okay, well, we know 2 points that are on BD. I'm going to choose one of those, okay? I'll put the y value here, so -1. I'll put the x value here, -7. Does that get me an equation with one variable? And we'll solve for that one variable. So I get -1 is equal to 7/2 plus b. I'll subtract 7/2 from both sides. It'll give me b to be -9/2. Okay with everybody? So now that you know b, and this is kind of where I don't think that this process is very insightful. Now you know b, you'll come back up here, you'll plug it in there. And you already know m, so you'll plug it in there. And when I do that, my m was -1/2, my b is -9/2. So that's my equation. Okay? You could have gotten the same thing if you would have used -3 as your x and your y. Just to show you that it doesn't matter and how much quicker I think this gets me my result. If I go y minus y1, so the +1 now, is equal to -1/2 times x minus -7, so it becomes +7. If I distribute my -1/2, I get y plus 1 equals -1/2 x minus 7/2. If I subtract from 1 from both sides, do I get -9/2 right here? And that gives me the exact same equation. Okay? So those are our two equations, and those are the processes that you are free to use at your discretion whenever they ask you to come up with the equation of a line. Okay? And like I said, this is going to be something that is common. All right? Chapter 5, we are going to do this a lot. Okay? So I want to make sure that we're kind of introducing this and getting our memories jogged from last year on how to do this. Okay? Now, here's the idea. If we want to find out the location of C, that's the task of why we had to come up with those equations. I want to find C. Well, you agree that's where these two lines intersect. If those two lines intersect, then that point of intersection, that x comma y of C, is on this line, or it's a point that will satisfy this equation, meaning that if I put C's y value here and put C's x value there, the left-hand side will be the right-hand side. It will be the same. And it'll be exactly the same down here. That'll work down here. Okay? So what we're saying then is that at that point of intersection, these two values are identical. Does that make sense? If those two things are identical, doesn't it mean that 2x plus 8 has to be identical to -1/2 x minus 9/2? Because remember talking about systems equations? That's a system equation. That's a substitution technique for solving a system equation. Now, I don't like that equation because there's what in it? What are these things? Fractions. Don't like that, right? You can deal with it. You want to add 9/2 to 8? That's fine. But when you add 9/2 to 8, you're going to have to change 8 to 16/2, aren't you? Okay? If I want to add 1/2 to 2, that's fine. Well, I have to change 2 to 4/2. Absolutely fine. Okay? But the easier thing to do is to find the LCD, the least common denominator. Okay? And multiply every single thing by that. Okay? And it doesn't really have to be the LCD. It just has to be a common denominator. Okay? So I'm going to multiply everything here by 2. And that's going to give me 4x plus 16 is equal to -x minus 9. Is that an equation that's pretty easy to solve now? Add x to both sides. Subtract 16 from both sides. And x will give me -5, right? So now what we just found then is that the x-coordinate of C is -5. We have to find the y-coordinate. These two equations tell you what y is, if you know x. Okay, now I would probably work with that equation because there's no fractions there, right? I plug x in, I'm going to get y equals 2 times -5 plus 8. 2 times -5 is -10, plus 8 is -2. So I have -2 there for that y value. Okay? So we've done that here. Same thing happens. What happens? Now I'll get -1/2 times -5 minus 9/2. Well, -1/2 times -5, that's 5/2. Okay? 5/2 minus 9/2, that's -4/2, right? -4/2, is that the same thing as -2? Okay? But obviously you see it's a little bit messier using those fractions. All right? Now the purpose we had to do that work was so that we could find eventually, I'm not going to do all 4 of these, but so I could find the distance of maybe B to C. Because now we'll take the x values of B and C and subtract them, square that quantity, take the y values of B and C, subtract them, square that quantity, and now I will have the distance of that thing right there. Does that make sense to everybody? Okay. The overall goal of this question is to be able to classify whether these triangles are congruent or not, and then explain why. Okay. Well, what we're going to find out, based off what they're asking us here, is let's find AB, which would be this length right there, right? And find DE, which is that length right there. Those are the sides that are opposite your right angles, correct? Are those hypotenuses? The next thing they're going to ask you to do was to find BC and DC. You're going to find out that distance there and that distance there are the same. So that these 2 triangles would be indeed congruent by hypotenuse legs. All right? Okay. A lot of algebra involved in that, right? Okay. You're going to find out, and this is, I battle this every year. Your algebra skills are going to be challenged. Okay. And I'm trying to give you that foresight that in the next chapter, if we're going to struggle, if we currently struggle with those equation things, you have, probably about a week and a half that you're going to have to work on your own until we get to this stuff in chapter 5 before we start using it quite a bit. Does that make sense? So in that week to week and a half, please take the time to review that Algebra 1 information. Okay, I've got so many resources on my website for that. You can get YouTube, Google, whatever. Just type in, how do I come up with an equation of a line, and you will be taught how to do that, okay, with videos, PDFs, all types of resources. Okay? Okay. I'll also post that video as well on the website. Currently, on the website, there is, under section 4.6, there are 3 videos that are just dedicated to coming up with equations of lines. So if you're struggling on that question in 4.6, please watch those videos. This assignment out of 4.5, people have been asking me about question 28. We want to, and I forgot to add this in there, but we want to assume that those lines that look like they're parallel are parallel. Okay, that'll help you solve that one much quicker. So that line there is parallel to that line there. Okay. That is due on Monday. That worksheet's due on Monday. I gave you that worksheet in an email. You're going to have to plug those answers into Math Excel. Okay, so that's available. 4.5 coordinate proofs is available, and 4.6 is available. I think you're going to see that 4.6 has some of the same types of questions that 4.5 coordinate proofs had in it as well. In addition, you have an optional review open, okay, for tomorrow's test. So you guys can work on those things for the remaining time. Work on those, ask questions about those. Please prepare yourself for tomorrow's test accordingly written.